So in today's class, we will start with the word segmentation algorithm. And word segmentation algorithm is a tokenization algorithm which works very well for Chinese. So that algorithm is actually called as maximum matching algorithm, which works on greedy strategy. Okay. So let's see. So the prerequisite of this maximum matching word segmentation algorithm is that it requires a word list. Word list is, I may also name it as a dictionary or simply list of words, right? So given a sentence, we put a pointer there and we move the pointer, and then we see the beginning of the pointer and the end of the, we see the first pointer and we see the we move the pointer one by one at each character, and then we see whether that word is present in the dictionary or not, right? So we every time see that the word, if it is present in the dictionary, that is the longest word or not, right? So as an example, so we move on to this character by character, we place the pointer here, okay, then we move the pointer comes here. Now we extract the word. So this was the starting place, so this word gets extracted, and then we see whether this particular word is present in the dictionary or not. So if it is present in the dictionary, then we move on to the next pointer, the next character. So this pointer is moved on here, right? So if this one is present in the dictionary, and then we will move on, but we see that WEC, this is not present in the dictionary, so we don't go for this word, we go back to the previous word, right? And then we take up this word and add a delimiter here, right? And then again we move on the pointer. So instead of saying that I am having a single pointer, let me say that there may be two pointers, right? So this is the starting pointer, okay, and we move on with the forward pointer, and this is the start pointer. So we move the forward pointer, and then we get the starting and the end part of a particular word. So this WE now becomes a word here. So this WE has to be looked into the dictionary. A lookup into dictionary is made. So this is present, fine. Then move on this one, the forward pointer. So now next word is WEC. WEC is not present in the dictionary, so we don't take up this WEC. We go back to WE and take up this one, right? So now let's see the algorithm, what the algorithm says. So in simple terms, the algorithm says that starting a pointer at the beginning of a string, find the longest word in the dictionary that matches the string starting at the pointer, right? Move the pointer over the word in the string, and again do the same thing. Now the exact algorithm says that we have a sentence and input sentence, and we have a dictionary. So this input sentence is, we can only see a short distance ahead, something like this, and we are assuming that we are doing this for English, and we also discussed that this does not work well for English, but for the sake of studying the algorithm, how does it work, we are doing with respect to English. Otherwise, it works very well with the Chinese, right? So, if the sentence is empty, then the return empty list. This is simple. So, we have for I is length of sentence, right? So, we give I as length of sentence. So, we move from one. We have a loop that moves from length of sentence up to 1, right? Then the first word I is first I character of sentences, right? So first I characters of the sentence means the all these characters, right? And remainder is the rest of the sentence. So at first instance we are taking all the characters in the variable first word, and the remainder is taking the rest of the sentence. Now if in dictionary, so what we are searching, if this whole thing is in the dictionary, right? If this whole thing is in the dictionary, then return first word, again it is recursively calling the same thing, remainder comma dictionary, right? So this algorithm is again going back, okay, recursively, and now the remainder part of the sentence, the string has been passed to the same algorithm along with the dictionary, right? So now the remainder part, you see here what I is taking here is length of sentence down to 1, right? So we are reducing here the length 1 by 1, okay? So by reducing the length 1 by 1 and every time matching the remainder, any of this largest will be get matched, right? So this whole thing has been given, right? And then finally we get back to this one. So this will give the largest that matches with the dictionary, right? Then we again extract this one, extract this V part, and then say remainder is what? Rest of the sentence, right? So in this way the algorithm proceeds. Right? So this is the maximum matching algorithm. So let's see again. So this maximum matching algorithm says that we have a sentence, we have a dictionary, returns word sequence W. Okay, so in the input this is the sequence of characters and the output is a word sequence, and we see in the output that each of these words are present in the dictionary, right? So initially if the sentence is empty, then return empty list. Then inside the loop we have, let's count, 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20 21 22 23 24 25 26 27 28 29 30 31. Alright, so we take a loop 31 to 1, okay, and then I say first word is the first I characters of the sentence, okay. So this is loop is actually for I is equal to 31, so first 31 characters, that means whole thing, and remainder is equal to rest. So rest is right now nothing, it is simply some empty string, or let me write it null. So if in dictionary, so I need to search this first word in the dictionary again. Okay, so this first word has to be looked up into the dictionary. Now if this whole thing, if in dictionary means that I am looking that particular word in this dictionary, right? So if this is present inside the dictionary, then it is fine. Okay, it will again give the first word and remainder part. So this maximum matching is again called, right? So what will be the return? Return list will be the first word comma maximum match. Okay, so if the whole thing is matching, then it will be returned, otherwise it will not be returned. Why? Because this condition, if condition will become false. So here we see that if condition will become false, right? So we come back to the loop here, we again reduce it, and we see that all the loop is here will not match until we get back to the V part, this V part, right? So this, all these words one by one get removed. Okay, and then we get the V part will match, and then V part will be returned with maximum matching and the remainder. So this V part is returned, so output, this V part is returned with recursively this remainder part, is passed here along with the dictionary. So now again when it will be called again, this whole thing except V will be the input for the algorithm, and it will again start from the last part, and it will again, now it will take this canon part. So next return will be the canon, right? In this way the algorithm works. So at the end, if no word was found, so make a one character word. First word is equal to first character of sentence, remainder word is equal to the remainder of sentence. So that means this whole thing is actually not, anything was not found. In that case, make a one character word. So it means that I am assuming this only as a one character word. Now after canon, after this one, after this we see that this whole, anything will not match in the dictionary, right? So I extract one character, make it a word, right? Remainder will be the remainder part of the sentence. Okay, so this becomes the remainder and this becomes the word. This is the word or first word, and this is the remainder. Now this remainder is again passed here as a return list, right? So in this way the maximum matching algorithm is working. I hope you understand this. I don't need to explain it again, right? Let me know if I need to explain it again. I hope this is fine with you, right? So this is again an example is given, another example, the cat in the hat. So the cat in the hat is working good. We see the output is very good. But in another example, the table down there is actually the must be the actual output. This is the actual, but the algorithm gives theta bled on there. This is by algorithm, by maximum matching algorithm. Okay, so it's generally don't work very well with English. Okay, but it has been observed that on Chinese it's worked astonishingly very good. Right? Now let's move on to some more discussion on normalization. Now here in normalization we see that we are being given two examples. Information retrieval, you can understand it as a theoretical term for search engine, right? We give an input query and we take some results from there, so that is called as information retrieval. So in simple terms, so we assume that information retrieval is only for text, right? So indexed text and query terms must have the same form. Indexed means that all the documents in which the query will be searched are given some numbering, some kind of indexing, document 1, document 2 and all, and we have the two documents, we have the two terms u.s.a and USA, right? So now these has to be converted into some single form. Either I have to convert this as u.s.a or I have to convert this as USA, right? Otherwise there will be discrepancies. So this is also the part of normalization. So in most of the cases we remove this USA and make it USA, but again I say that it depends upon the specific type of task and problem. So we implicitly define the equivalence classes of the terms, like example deleting the period in a term. So we delete the period or we may not delete the period, right? Similarly, the capitalization here, if I give the input term as window with small w, so it will be windows or windows, window or windows, right? So for this one the search may give this one, the search may give this one, but this is quite different. Windows WI in capital W, it will be the Windows, that operating system, but this small w will lead to the windows of the house, right? So we again need to take care whether we need to perform the case folding, that is, case folding means converting all the things into the lower case. So whether that is required or not. So in case of some special names like person name, proper nouns, these person names and location names, so in these cases we may require not to apply the case folding, right? But at the end we observe that all these things are very, very powerful but less efficient. It means that it is very difficult to apply such kind of algorithms that very accurately or efficiently discriminate between these two, or they may assume that these two things are same, right? Similarly, case folding, again I told earlier that reduce all the letters to lowercase, again if it is required by the problem in case of General Motors. So this General Motors is, if we take it without the first letter capital, General is again a very simple dictionary word, Motors is also a dictionary word. Now the problem becomes more complex now, right? Similarly, Fed versus Fed means Federation Bank or something like that. Sale versus sale, so this is a short form of some organization and this is a dictionary word. And similarly, in case of sentiment analysis or information extraction or any other task, case is helpful because US is again short form of USA. So US means United States, but here US means us. So these are the things that occur in normalization and which are very very difficult to deal with. So lemmatization is reducing the variations of a word to a base form, right? So inflection means a variant, some surface form. So I can also call it as a surface form to base form. That base form is also called as lemma. So lemma may not be actual the surface form. So lemma may be present in may not be present in the dictionary, but words may be reduced. May be possible that word is reduced into a lemma, but that particular lemma is not present in the dictionary because the surface forms are used in actual communication or actual conversation. Okay. So these are some different specific kinds of lemmas. Like B is the lemma for am, are, is, right? Similarly, we need to again perform here. Car, cars has to be reduced to car. Given a sentence, the boy's car are different colors, so the boy car be different color, right? Have to find correct dictionary head word form, right? Now this is an example given in for Spanish. This quiero means I want, and queries means you want, and the lemma for both is same, that is querer, that is want. So in case of Spanish, we have single word for two words for both these words. So I want in English it is two words, but in Spanish it is same word. So the same, so the same lemma is present for both these words. Morphology is the study of words, right? So study of words includes again study of stems and study of affixes. What are stems? Stem is again going to the core base form or lemma form or something that is at the stem that produces much more surface forms, and by including the stems and affixes together, by combining them, we get the surface form words, right? So affixes are those that are added to the stems like ed, ing, s. These are called as affixes. So affixes may also be in the form of, mostly they are suffixes. Okay. So as an example, so in morphology we study what are the stems and what are the affixes, and then we study the stemming also. So stemming is another term that is quite similar to lemmatization, but lemmatization is actually taking everything into consideration, but stemming is by taking not all the things into consideration, but depending upon the task what we have to perform. So that's the difference between lemmatization and stemming, right? So stemming is just crude chopping of affixes, right? So like in the word automate, automatic and automation, in all these three words they may get reduced to automat, right? So as an example given here, for example, compressed and compression are both accepted as equivalent to compress. So we see what is the stemming, how stemming is done here. For example, we see this E is missing here, compressed ed is missing here, and compression again SSION is missing here, E is missing here. Both accept as equivalent LENT is missing here to compress again, right? So this is all stemming here. stemming we have done by some rules. I am just cutting off some end part of the word and trying to make it into the base form. Now, Porter's algorithm is a very popular algorithm and is a very old algorithm which works good, but as compared to the latest machine learning algorithms, this is very old one, right? But this works well, around 70-80% it is accurate. So these all connections are the surface form words of a same stem. Okay, so we need to remove ed, in this we need to remove ing, in this we need to remove ion, in this we need to remove ions, right? So anywhere they appear in the corpus, they have to be get converted into the connect. So what is the Porter's algorithm? Porter's algorithm is actually the step-by-step application of some rules. Step-by-step application of some rules. So Porter and some other natural language scientists at that time, they said that the word is actually composed of vowels and consonants. So either the word start from vowel, then consonant, then vowel, then consonant, then vowel and consonant, etc., and then it may end on a consonant. Similarly, vowel starting with vowel, consonant, vowel, consonant, vowel, consonant, and then ending with vowel, and vice versa, starting with consonant, then vowel. So here a single C, it may be a group of consonants, or it may also be, I will just write it, a single one. So it may end on a consonant, and again starting with consonant, vowel, consonant, vowel, consonant, and so there are 4 types of words that are available. So I say that this is VC and VC star here. It's like this. So I can write it like this. Consonant and then VC to the power M and then vowel. So I am assuming just one form in which this general form in which VC represents or denotes the repeated VC. That means I may have m is equal to 0, m is equal to 1, m is equal to 2. So if I have m is equal to 0, it becomes only CV, right? So for m is equal to 0, it becomes CV. For m is equal to 1, it becomes CVCV. For m is equal to 2, it becomes CVCVCV, right? So this VC to the power 2. Okay. So this bracket denotes that the occurrence of C may be either 0 or more than 0. Occurrence of V may be either 0 or more than 0. So again, if any of these are not present here, so the form may change, whether it is, if this C is not present here, it is only a vowel here, like a. Similarly, if this C is not present here, okay, it is a vowel, right? A, R, E, R, something like this, right? So this is designated as a general form. Okay, and we apply different values of M for having different combination of words, right? So the Porter-Stemmer algorithm says that there are different steps, step by step, and each steps are having some series of operations. Each step is having some series of operations. Okay, so the step 1 says that SS has to be eliminated with SSES has to be replaced with SS, and IES has to be replaced with I, SS with again same SS, and if there is a single S, it needs to be replaced with space or null. So KRS, this gets eliminated here. Ponies, okay, IES is replaced only by I. Sorry, in the first one it is SSES is replaced by SS. So this gets done away. This gets done away. Right, now again this we see that we are getting this one, and again in the same step we are applying CARESS. On this we need to again check out, so it has to be kept intact, but only S is left. Then we can have cats to cat, right? Similarly, step 1B, so star V star, again anything that is present, that is preceding the vowel and it is after the vowel, right? Anything that is preceding the vowel and after the vowel. So in that case, this means that that is some combination of words, combination of characters that is having a vowel in it, right? Any word or any combination of letters that is having a single vowel in it, right? And it is suffixed by ing. So like walking, so this A is present as a vowel here, so I need to chop off this ing. But in case of SING, no vowel is present here, it is a only single consonant, so nothing is done here. Similarly in case of ED also, so this vowel, this also vowel is present here, right? So this ED will be chopped off, right? But in case of some words like king, like spring and thing, so you see that this ing is remaining here. Similarly we have some more rules. Okay, so this Porter-Stemmer algorithm has more number of rules. It is having step 2 is also there. So step 2 is having these are not complete rules, there are some more rules that are present here, right? In case of step 2, so lot more rules are here. In case of step 3 also, lot more rules are here. And then we have step 4 also. So this is an example of step 2 part B here, where we have already discussed. And so step 5A and 5B also is present here. Step 4, then step 5A and step 5B. So there are 5 steps. So we will be discussing these in more details in the lab classes. While we are doing the program on the Porter-Stemmer, we will be discussing this Porter's algorithm in more detail, right? So this is all about the Porter's algorithm for now, but we will have an additional lab lecture for Porter's algorithm also. All right.